test the series n equals 1 to infinity, -1 to the n, 3n over 4n minus 1 for convergence or divergence. So for this series, what would our B sub n be?
1 over 4n minus 2.
So you've got the,
3n for 4n minus 1.
3n, because you also want to include that other term. We're just gonna, when we come up with our B sub n, the only thing we're getting rid of is this piece right here, okay? So 3n over 4n minus 1. So sometimes when I'm doing these problems, I'll start with the second condition, the limit part. Especially in this case, it's really easy for me to calculate this limit. So I'm looking at the limit as n goes to infinity. I'm focusing on condition 2 right now. (3n over 4n minus 1). So we're getting infinity over infinity for that limit, which means we can use L'Hopital's rule, but I also want to give you another way of doing it without using L'Hopital's rule, just to remind you, you don't have to use L'Hopital's rule. So this is a polynomial over polynomial, so I can take the highest degree term. So in the numerator, my highest degree is 1. Denominator, the highest degree is 1. So I multiply top and bottom by 1 over n and distribute 3 over 4 minus 1 over n, and that limit is now going to be 3/4. Okay. I needed to get 0, right? But I didn't. So what that tells me is well, that's the tricky part. I said that the alternating series test only tells us that a series converges, right? You have to try something else. And so this was not 0. So this tells us that the alternating series test is inconclusive. And the reason why it's inconclusive is because, again, the alternating series test only tells us something converges. It doesn't say anything about diverging. And so when the alternating series test fails, you jump to using the divergence test. If you wanted to use comparison tests, what are the conditions on a comparison test? Your series, it has to be positive, so I can't use a comparison test for alternating series. So we're going to jump immediately from here to using the divergence test. So I'm looking at the limit as n goes to infinity. It was -1 to the n, and then I had 3n over 4n minus 1. And what we said is the limit of this positive part here is 3/4, right? So here's where we're going to have to think about our sequence as like a list of numbers, okay? And remember, it's alternating. Every other term is positive, the negative, positive, the negative. So every other term, positive, negative, positive, negative. All of the positive ones want to go to the number 3/4 because the limit of the part I've underlined is 3/4. So every other term, it wants to go to 3/4. But then all the negative terms want to go to negative 3/4.
So is that the bounds, 3/4 and negative 3/4?
So we're trying to calculate this limit. So we're trying to see if these numbers get close to a certain number, right? But right now, they're spread out too far. Okay? My terms go here, 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 and they stay far apart. So that limit does not exist. Okay? So this limit does not exist. Remember how the divergence test works. If I get anything other than 0, in this case I got does not exist, that's not 0, so the series diverges.
Can you explain how it doesn't exist?
Yeah, so you're taking a limit of this is really like a sequence now, these terms here, okay? So I'm plotting them out, which I haven't done formally for you, but you plot them out, and you have this up-down thing because every other term is positive, and then negative, positive, and negative. And I said that the limit of this part, 3n over 4n minus 1, we calculated that limit to be 3/4. So all the positive terms want to go to 3/4, but the negative terms are going to want to go to negative 3/4. So if I look at what's happening, my numbers are staying spread apart. They're not close together. And so that's why the limit does not exist, because to exist, I need to approach a single number.
So if the negative 1 to the n wasn't there, the limit would be 3/4.
The limit would be 3/4, which we calculated a little bit before. Yeah, I calculated it up here. 3/4. Okay, so this series, let me put that here. This series, negative 1 to the n, 3n over 4n minus 1, diverges by divergence test. Okay, so again, you're not saying it diverges by the alternating series test, because the alternating series test only tells you that something converges. Okay. And this is how it'll work every time you get a limit that's not 0. You'll switch from using the alternating series test to using the divergence test.